Welcome to our educational channel. In this video from class 8th Mathematics, Chapter 5, Playing with Numbers. So let us come to the topic wise first. So from this chapter, first let us see some basic introduction of this playing with numbers. So especially in this natural numbers and whole numbers, integers. Integers we can denote with capital Z or I, and along with this rational numbers, factors, multiples, those we'll see in this. And generalized form of numbers. So how to generalize? How to write in general form the numbers like 2-digit number, 3-digit number. So any number, how to generalize and writing, let me explain in this. And some interesting properties. So it's like puzzle based questions also, I'll explain in this. And the important thing is the letters for digits. This cryptarithms like 3 1a plus 1a3. So the answer is if it is 501. So what is in the place of a? How to find the number? So let us for the digits. Instead of digit, the replaced by letters. How to find out those? Okay, there is a cryptarithms. So few examples I explained in this. And test of the divisibility. So what is the divisibility rules for all the numbers, which is required for this standard? So rules for the divisibility rules. I'll explain here. And based on that divisibility rules and problems, so how to solve the word problems based on this test of divisibility, right? These are all the topics. Let us see one by one. Generalized form of numbers. So to understand the concept of the properties in this interesting numbers, properties of the playing with numbers, so we need to know the number generalized form. So according to that, let us take the 2-digit number. So a number is said to be generalized form when it is expressed as the sum of their products of the digits with their place values. Let us take one example, 63. So 63 means 6 is in 3 is in units place, 6 is in tens place. That means this is exactly equal to digit 6 is multiplied with its place value, right? Plus again digit 3 into its place value. This is a generalized form. Already we learned previous classes. Just I'm revising, recalling again those. That means finally we can write 63 is equals to 6 into its place value is 10 plus 3 into its place value is 1. Units place, tens place. So place value is 10. So same way 6 into 10 plus 3 into 1. So writing this format is generalized form. Right, simple. Again, let us take one 3-digit number. So if we take a 324, that means digit in hundreds place into its place value is 100 plus digit in tens place, second digit into its place value 10 plus 4 is in units place, its place value is 1. So 3 into 100, 300 plus 20 plus 1. This is making like this is general form. Let us take one example. Let's A is in tens place. A is in tens place, and let's say B is in units place. Then the value of that number. Generally, if you write AB like this in mathematical formation, this is nothing but A into B, A times B. But if you write number 63, it's a 63 only, it's not 6 into 3. So instead of getting confusing with the variables and numbers, so in the playing with numbers, to understand the properties, we generalize it. Now A is in tens place, so A into 10 plus B is in units place, so B into 1. This is 10A plus B. So there is not AB, because AB is nothing but in algebra and mathematical notations. This is A is multiplied by B, there is no symbol. So instead of writing, the number is which is in tens place is A and units place is B, the number is this 10A plus B. So this is the generalized form. So generally normal numbers we can make it as easy, but when it comes to the variables, we have to generalize in this way. Let us say A, B, C. So A is in hundreds place, B is in tens place, C is in units place. Then that number is 100A plus 10B plus C is the number. Instead of A, B, C, any number you can keep, then value will come. For example, A is 2 and B is 3, C is some 4. Then answer is 2 into 100. So 200 plus 30 plus 4. That is 234. 234 is the value of that number. But should not write like A, B, C directly without giving gap means is nothing but multiplication in algebra. So generalized formation is particular digit value into its place value. So by adding those we can get this. So this is the formation of generalized. Any number, not only 3 digits, even 4, any number of digit value we can make in the same way. So this concept you just remember, because these one only will apply in some interesting properties now. Some interesting properties. So after knowing the generalization form, let us see some interesting and some basic properties. I will explain three important properties in this. For example, okay, let us take the number AB. Actually, the AB is in generalized form 10A plus B. Okay, A into tens place. So 10 into A, 10A plus B. And the reverse of this number, that is BA. That means 10B plus A. Instead of taking the number, just write generalized. For example, if I take 23, then we can write 2 into 10 plus 3 into 1. So that is 20 plus 3. Right? Apart from the numbers, only with variables, let me explain first property. Let us take any one number and reverse the number. AB is the number and BA is the reverse of the number. By adding these both, that means AB plus BA. So that is equals to 10A plus B is the first number plus 10B plus A is the second number. So by adding these both, 10A plus A, so 11A, B plus 10B, 11B. If you take 11 common, then A plus B. The meaning of this is any two-digit number you take and reverse that number and add, that value should always divisible by 11 or sum of the numbers. So with example I'll show you, it will be clear for you. Take number 35. So 35 reverse number is 53. Now 35 plus 53, if you add, the result 35 plus 53 is 88. This always is divisible by 11 or else the sum of the digits. So now 88 is divided by 11, same 88 divided by sum of the digits, 3 plus 5, 8. So is the rule. When AB and BA is divisible by 11 and quotient is A plus B. If it is divided by A plus B, then quotient is 11. Clear? Take any number, not only 35, any other example. Say 87. 87 is the number. And reverse the number 78. Just add those numbers. The answer is always divisible by 11 or sum of the digits. So 7 plus 8. So 15, 1 carry 15, 165. Now 165 is always divisible by 11. If you divide with 11, the remainder is sum of the digits. So that is 8 plus 7, 15 will come. Same 165, if you divide with sum of the digits 15, the remainder is 11. Because the product of that 11 and sum of the digits itself, the sum of the numbers. Right? So this is the property 1. Second one, let us take the same numbers and subtraction rule, let us check it. Now AB is a number, that is 10A plus B, right? And BA is a number 10B plus A. By subtracting these both, what will happen? First number minus second number, AB minus BA. That means 10A plus B minus 10B plus A, second one. So next step, 10a plus b, minus into 10b is minus 10b, minus into plus is minus a. By subtracting this, 10a minus a, 9a plus b minus 10b is minus 9b. Take 9 common, then a minus b. So one thing you can understand is, take any number and reverse it. Take example 73, and reverse of that number is 37. If you subtract this, the result is always divisible by 9 or difference of the numbers. 73 minus 37. Just subtract this. 13 minus 7, 6. So 36. So 36 is always divisible by 9, or 36 must divisible by difference of the numbers. 7 minus 3, 4. So if we divide with 9, 4 is the remainder. We divide with 4, 9 is the remainder. Because difference of the numbers only, we are getting 9 into a minus b. Just if we generalize, we can come to know the rule it is. Okay, any example, even you take, so for example, 38. If you reverse 83, so right here a and subtract. 83 minus this 38, which will get 45. So 45 is always divisible by 9 and always divisible by difference of the numbers. 8 minus 3, 5. So divisible by 9 or else divisible by 5. Perfect divisibles. Okay, so this is the property 2. This is the first one is adding, second is subtraction. Let us take a 3-digit number now. Take 3. So consider a 3-digit number ABC. ABC. Okay, let me show with example. For example, take any one number like 374. By interchanging this ABC, make other 3 numbers ABC, BCA, and other number. So CAB. That means same 374 starts with 3. 374, 743, again 437. Take any number, 3-digit number, by changing the numbers, just you can do addition of this. So what will happen? Now ABC, this is a 100A plus 10B plus C. Second one in generalized form, 100B plus 10C plus A. 100C plus 10A plus B. So by adding these 3 numbers, 100A, A and 10A, total 111A plus 111B plus 111C you got. From this you can take 111 common, then A plus B plus C. So one thing you can conclude, by adding any 3 numbers by interchanging the places, now that result should be divisible by 111 or sum of their digits. Okay, now in this example, 374, 743, 437. So if you add 10, 14, and 5, 5, 4. 1554. So 1554 is always divisible by 111, or same 1554 is must divisible by sum of the digits 3 plus 7 plus 4. I took only 3 digits in the place of ABC. So 14. Right? If I divide with 111, the answer will get 14. If I divide with 14, the answer will come 111. Because the product, the sum of that numbers is 111 into A plus B plus C we got. So we can generalize and we can come to know by adding or subtracting if the question is coming in examination. So we can find out the property exactly. Okay, there are the questions. Find the quotient when 821, 218, 182 divisible by 111 or not. So observe the question and account that you can make it. Okay, this is the main basic thing. The simple properties. Other properties also you can make as per this one. Latest for digits is cryptarithms. Generally, we know that cryptarithms is a type of mathematical game consisting of numbers whose digits are represented by the letters. So we have to identify the value of the each digit. So each letter value we have to identify. So that concept we'll see here now. And how to identify, let me show a few examples. So as we discussed in introduction, let me show you one question like previous. Now 31A. So like 312 or 311, 312. You don't know in the place of A what number will come, you have to identify. This is adding with 1A3 and the result is 501. So in the place of A, what number if you replace, this answer should exactly equal to this. Now these type of questions, some we can by seeing guess the answer. And as per the rule, first we need to take this list, right? Number plus 3 is 1. So A plus 3, units place must be 1 in this case. Now the first we have A plus 3 is equals to 1, or A plus 3 is equals to 11, because units place must be 1, or A plus 3 is equals to 21, so on. So 31, 41, so on. Now next, from this A value you can identify. A may be 1 minus 3, or A is equals to 11 minus 3, or A is equals to 21 minus 3. Okay, 3 take right side, subtraction and so on. Now that finally the value of A must be either minus 2, or A is equals to 8, A is equals to 21 minus 3, okay, 18 and so on. So next to 28, 38 will increase. Now by observing here, A value should not be negative. So it is or not. Then we should not take this. Then A value is 8, A value 18, so on. So in this case, A is not equal to 18, not equal to minus 2 and so on. Even not 28, 38, so on. So finally A value must be 8, because in the place of A is a single digit, right? So first step, since A is a digit, then A is equal to 8 we got. Let us check here the rule. Checking 318183. The answer is 501. By adding this exactly we'll get. It satisfies the rule. 8 plus 3 is 11, 1, 9, 1, 10, 1 carry, 4, 5. So 501. Right? So A is equal to 8 satisfies the addition in tens and hundreds columns. So this both place. So tens, hundreds column it satisfies this both. So we can take this. This is the pattern. If you frame, then you can identify the value easily. Let us take the two numbers. For example, B9 plus 4A. Okay, the value is in this 65. So same pattern if you observe clearly, 9 plus A, this units place. 9 plus A, it must be 5, or 9 plus A, it must be 15, or 9 plus A, it must be 25 and so on, right? From this A is equals to 5 minus 9, or A is equals to 15 minus 9, or A is equals to 25 minus 9, so on. As of now, A is equals to minus 4, A is equals to 15 minus 9, it is 6, A is equals to 25 minus 9, so 16, so on. It will increase now. So finally, the value should be single digit, not negative. The value is equal to 6. So A is equal to 6 only can satisfy this. Right? Now the first statement is clear. Then if you replace, in the place of A, if you take 6, 9 plus 6 is 15. So 1 carry over here. Now 1 plus B plus 4 must be 6. Then next 1 plus B plus 4, it should be equal to 6 now. From this you can identify the next one. So 1 plus 4, that is a 5. 5 plus B is equal to 6. So from this B should be 6 minus 5, that is 1. So in the place of B, it must be 1. So A is equal to 6 and B is equal to 1, satisfy this. That means 19 and 46 is exactly equal to 65. So in the place of A is 6, in the place of B it's 1 it is. So this is the replacing the digits with the numbers, means this is the concept you can apply. Even let us take the 3 digit number. One more example I'll show you. In question, let's take 8a5 plus 9 4a. Even units place and tens place house is there, but pattern is same from the starting, and result is given 1a 3 3. In single line, will satisfy or not, you have to check, because 5 plus a, it must be 3, or 5 plus a is equals to again 13, right? Because 3 must be in units place, or 5 plus a is equals to 23, so on. So a may be 3 minus 5, or a is equal to 13 minus 5, or a is equal to 33 minus 5, so on. From this, a is equals to minus 2, or a is equals to 13 minus 5. So I can subtract this 8, or a is equal to 13 minus 5. So 18, so on. A must be single digit, so that's only the place is this, not negative, not more than one digit. So a is equal to 8 will satisfy, check this. In the place of a, if we keep 8, we can identify 5 plus 8 is 13, 1 carry, 9 plus 4 13, 9 plus 9 18, yes. So a is equals to 8. No need of by seeing the entire question instead of getting confusion, just from start the units place, from there you can check. Okay, this is a simple and technique to identify for the basic questions in this cryptarithms. Tests of divisibility. So in this topic, actually we need the divisibility rules for all the numbers. So as per the required of this topic, let me show you a few now. So first we'll start with easy numbers. Instead of for all the rules of the divisibility rules, the basic numbers what we need. So the rule for 10, easy ones you see first. So rule for 10, which number is divisible by 10? So a number is divisible by 10 if its units place is 0. So always the number is units place is 0, that is exactly divisible by 10. We know that, right? So 10, 20, even 320 or 440, units place must be 0. Then that number is divisible by 10. Then what is the divisible rule for next one is 5. 10 is simple, only by checking the units place. If it is 0, that is divisible by 10. Now rule for 5, a number is divisible by 5 if units digit is 0 or 5. So in this, units place is 0 or 5, either 0 or 5 if it is in units place. In this case, only units place must be 0. Then these are the examples. Same way for the divisible rule for 5. So example 25, 30, 445. So units place is either 0 or 5. Is divisible by 5. Now then divisibility rule for 2. So rule for 2 is, in this case all the even numbers are divisible by 2. That means the units place is 0 or any even number. So that means units place 0, 2, 4, 6, 8. Any one of this number in the units place, that number is divisible by 2. So 6234. 4 is in units place. So this number is divisible by 2. 604. 4 is in units place. Right? So 326. 6 is in units place. So units place must be even digit. Either 2, 0, 2, 4, 6, 8. Then that number is divisible by 2. Right? And rule for 3 and 9. First let me show the rule for 3. Divisibility rule for 3. Sum of the digits is divisible by 3, that number is divisible by 3. If a number is divisible by 3 means if the sum of the digits is divisible by 3. Let's take 645. In this, 6 plus 4 plus 5, 15. So if the 15 is divisible by 3, so 645 also divisible by 3. Same way, rule for 3 and rule for 9 is both are same. Rule for 9 is 3 means the sum of the digits must be divisible by 3. Here is the sum of the digits should be divisible by 9 for the 9 rule. So example 45,387. To check this number is divisible by 9 or not, you just add the numbers. 4 plus 5 plus 3 plus 8 plus 7. By adding this, you'll get 27. 27 is divisible by 9. So this 45,387 also divisible by 9. So remember 3 and 9 is the same rule. The number is divisible by, the sum of the digits is divisible by 3. That number is divisible by 3. Sum of the digits is number of the sum of the digits in the number divisible by 9. That number is divisible by 9. And any number is divisible by 9. It's also divisible by 3 because 3 table only 9 is there. Right. Next, come to the 6 rule for 6. Divisible rule for 6. If any number is divisible by 2 and 3. If a number is divisible by 2 and 3, then number is divisible by 6. So rule for 2, rule for 3, both should satisfy for the rule for 6. Right? We take 540 number. So in this units place is 0, so it is divisible by 2. And sum of the digits 5 plus 4 plus 0, it is 9. So 9 is divisible by 3, so this number is divisible by 2 and 3 both. So 540 divisible by 6. If anyone is not satisfied, that is not divisible by 6. For example, 300 so 6 7 and more 1, 3171. So 4 5 12. Sum is, this number is divisible by 3 but not 2, because 3 plus 1 plus 7 plus 1, 4 5 12. Sum is 12. This is number divisible by 3 but not 2, so it is not divisible by 6. If a number is divisible by 2 and 3 both, then only the number is divisible by 6. Right? Again, see the rule for 4 and 8. Divisible rule for the 4 and divisibility rule for 8. Both are explained in the same example. For 4 is the units and tens, the last two numbers. For example, 3516. If units and tens, the number is divisible by 4, then the entire number is divisible by 4. And for 8 is last three numbers. When you come to this 8, last three. Like 16,700, 16,000, this number you can take, 1,67,800. The last three are in 8 table. Last three are divisible by 8, that entire number is divisible by 8. For 4 is last 2 and for 8 is last 3 are divisible by that number, then the number is divisible by those. Right? And rule for 11, see this one rule also. Divisible rule for 11. So 12, 13, 14 all are not necessary as per your syllabus. So rule for 11 is, consider a number 61,809. When you come to this rule for 11, difference between the sum of the even places and odd places. So first number, third number and fifth number you can add. Second and fourth remaining you can add. 6 plus 8 plus 9, 1 plus 0. Sum of the even places numbers, odd places numbers. So this is 1 and it is 9 plus 8, 17 plus 6, so 20. So by adding this only you can get separately. So this is a 23. Now difference between them. So 23 minus 1, so 22. If the result is in 11 table or is divisible by 11, that number is divisible by 11. So a number is divisible by 11 if the difference between the sum of its digits in even places and sum of the digits in odd places is either 0 or divisible by 11, like 0, 11, 22, 33, so on. The number is divisible by 11. These are the basic properties we'll apply for the divisibility rules. and let us see the numerical word problems in this test for divisibility rules. Problems on tests of divisibility. So after you understand the divisibility rules, so let us see how the word problems are asked based on this divisibility rules, and let us solve this. So already we should know the perfectly this divisibility rules, then only we can answer this. The question is, if 42x, x is a number like 421, 422, 423, any number is divisible by 9, find the value of x. So 420, this place we should find out, right? Now as per the rule, 42x, so is divisible by 9, is divisible by 9. That means the rule for 9 is sum of the digits must be multiples of 9, right? That means 4 plus 2 plus x is divisible by 9. That means 4 plus 2. So 6 plus x is divisible by 9. Though that means 6 plus x value must be multiples of 9, 0 or 9 table again. So it may be 0 or 6 plus x is equals to 9, 6 plus x is 18, 6 plus x is 27, and so on. Okay, 9, 18, 27, so on. From this you can find out x is equals to 0 minus 6, no, minus 6 it is. And from this x is equal to 9 minus 6, so 3. From this x is equal to 18 minus 6, so 12. From this x is equal to 27 minus 6, so 21. If you observe this result, x is a single digit, so and not negative. That means this is not. Only x is equal to 3, right? So since x is a digit and x is equal to 3, 423 is divisible by 9 now. Right? Let me take one more example. One more question. If 24a5 is a 4-digit number, is a multiple of 3, is a multiple of 3 and divisible by 3. So find the value of a. Then find a. So find the value or values. How many values, or one or more than one, we will see now. According to the rule, multiple of 3. So divisible by 3. Rule for 3, sum of the digits must be multiple of 3. So 24a5 is multiple of 3. It's a multiple of 3. That means 2 plus 4 plus a plus 5 is a multiple of 3. By adding this, 2 plus 4 plus 5, 11. So 11 plus a is a multiple of 3. That means as per this rule, 11 plus a should be 0 also, because 3 times 0 is 0. Or 11 plus a is equals to 3, and so on. Or 11 plus a is again 6. 11 plus a 9. 11 plus a is 12, and so on. Right? From this, a is equals to minus 11, a is equal to 3 minus 11, then a is equal to 6 minus 11. From this, a is 9 minus 11, again a is 12 minus 11. So up to here, a is equal to 3 minus 11 is minus 8. This is minus 5, it's minus 2, and it is 1. So negatives you should not consider. That means a not supposed to be minus 11, minus 8, minus 5, minus 2. A is a single digit, and we can continue more. So a is equals to again 12. From this, 11 plus a is 12. So next continuation, if you do, 11 plus a is 15, or 11 plus a 18, and so on. From this, a is equals to 15 minus 11, it is a 4, and a is equal to 18 minus 11, so 7. So 1, 4, 7, and next one 11 plus a is equals to 21. From this, a is equal to 21 minus 11 is 10. So double digit will not take. Only the option we got, a is equals to 1 or a is equals to 4 or a is equal to 7 and not 10. Only 1, 4, 7 are the options. So a may be 1, a is maybe 4 and a is equal to 7. So finally a is equals to 1, 4, 7 out of these 3, and it can keep as a multiple of 3. Like only the value of a they asked. So a value 147. This way you can get it, and take one more. Let us take the one more example. Let me show you. Let's take the multiple of 3. That means 21y8 is a multiple of 6. Is a multiple of 6 and the value of y. Find the value of y. Right? So because it's a multiple of 6, it should be satisfies 2 and 3 both. That means 21y8 is a multiple of 2 and 3 both, right? And already units place is 8. Because of units place is 8, any number of any digit of y, it satisfies the rule because it's a multiple of 2. That's the rule. Now we should check for the 3 now. Now 2 plus 1 plus y plus 8 is a multiple of 3. Because for y is in the tens place, so 8 is already units place. It's compulsory any number of y, either in the place of y, any number like 1, 2, 3, 0 to 9, anything you can keep. It's a multiple of 2. Now we have to check only for the 3. Is a multiple of 3 it is. Only this one you have to check now. So 2 plus 1 is 3 plus 8, 11. So 11 plus y, it should be is equal to 0 or 3, 6, 9, 12, 15, 18, 21. Instead of writing so many times, just you can write keep dots. From this you can find the value of y. Y is equals to, so minus 11, 3 minus 11, no, minus 8, so minus 5, minus 2, 1, 4, 7, 10, so on. So based on these two rules, for divisibility rule for 2 means in the place of y, any number you can take. So since y is a digit, it can have values of 0 to 9 for 2. And for y is this overall common is only 147, because it should not be more than single digit and not negative numbers. So value of y is 1 comma 4 comma 7. It satisfies multiple of 6. So that means 2118, 2148 and 2178. That means 2118, 2148, 2178 are the multiples of 6. In the place of y, 147. Only value of y is asked. So till here you can solve this. Right? So divisibility rules based on that only. So we can find this word problems. So all the divisibility rules should learn thoroughly perfect first. Then only we can answer this is easy. Right? Who's watching the first time, right? You can see the some more videos for other classes, not only this class, even other chapters also. The link is provided in description below. You can just go through that and find out the other chapters and learn.